An electron travels horizontally at a constant speed of 9.40 times 10 to the 6 meters per second and enters a uniform magnetic field of 0.370 Tesla. So speed is 9.4 times 10 to the 6 meter per second, enters a uniform magnetic field of 0.370 Tesla, which is into the page. Sometimes these things are given as this, sometimes it's just this. But when you're not sure, you can always ask. Remember, this is an electron, so everything will be different now. Okay, so we have to always take care of that. Electron is going to be having minus 1.6 times 10 to the minus 19 coulomb charge. Now, on the diagram above, we're doing question number A. On the diagram above, show the direction of the magnetic force on the electron as it enters the magnetic field. So we're going to be using this formula, of course, with no electric field. So it's just Q V cross B. Now the direction of V cross B, the cross product will give the direction of the magnetic field. Magnetic force. So V is to the right. Okay, B is coming out of the page. So if you curl your fingers of the right hand from V to the out of the page direction, you'll see that the magnetic force is in this way, right? But that is only true for a charge plus Q, remember? But if it is minus Q here, what should you do is the answer will be just the opposite, right? So it will go like that. Just make that direction. It's gonna be like that. Okay. Again, for a proton, you do V, and it's coming out of the page. So V cross B will give you this as the direction of the force, but it is an electron, so it will go like that. Okay. That is your answer for part A. On the diagram above, we actually solved B. Okay, so part A says on the diagram above, show the direction of the magnetic force on the electron as it enters the magnetic field. So that would be just this. This is FB. And as far as the approximate path is concerned, you just make this. Okay, make a mess of it, but this will be the approximate path. Yeah. Calculate the magnitude of the force on the electron. So we're talking about just the magnitude, right? So let's make one thing clear, that FB is going to be QVBY, because the angle between V and B is 90 degrees. So when you do the cross product formula, there's a sine 90 in there, and sine 90 is equals to 1. Now that will be just QVB. So let's solve this real quick. Q is 1.6 times 10 to the minus 19. Remember, I'm talking about only the magnitude, so I don't really care about the sign at the moment. Times the velocity, that is 9.4 times 10 to the 6, going real fast. And the magnetic field is 0.370 Tesla. This gives FB to be, let's calculate this quickly, 1.6 times 9.4 times 0.370, and this comes out to be 5.56 times 10 to the minus 30 newtons. That's 30 newtons. Okay, that is the answer to the question, what is the magnitude of the magnetic force on the electron. Now calculate the acceleration of the electron. Okay. Calculate the acceleration. So this is also where they're trying to combine 231 and 232. So you have the magnetic force, right? And that will be equal to the acceleration. This means the acceleration will be just equal to Fb divided by m, and this will always be given to you, that is the mass of an electron is 9.1 times 10 to the minus 31 kg, and that means this is equal to 5.56 times 10 to the minus 13 over 9.1 times 10 to the minus 31, and this will come out to be 0.6 times 10 to the +18, that is equal to 6.1 times 10 to the 17 meters per second square. Okay, this is really fast. Let me just quickly check the mass of the electron. Yeah, that is correct. That is correct. Okay, it's 9.1 times 10 to the minus 31. So this is the acceleration. This is the answer for part D. Now it says calculate the radius of the path that an electron follows in the magnetic field. Okay, this is turning out to be a very good question that you should really do yourself. So calculate the radius of the path that electron follows on the magnetic field. So I'm going to make the diagram once again. You've got magnetic field here like that. Okay, and the electron goes like so. Okay. Now the thing is, like, it's going in a curve, right? So there's a centripetal acceleration to it that is directed towards the center. Okay, that is the centripetal acceleration. So if you can recall your 231, you should know that when a body is curving, like in a curve, like for example, if you're rotating a ball attached to a string, for example, there's a centripetal force towards the center. Okay, and that centripetal force is equals to mv square over r. But we don't have velocity, do we? Hold on. Okay. The velocity is given to us, and it's 9.40 times 10 to the 6. Alright, so this was a classic case of me thinking, me just not thinking actually. So velocity is given to us. Nice. It makes sense. So this will be F mv square over r. And the thing is, this balances the magnetic force, right? Because that is magnetic force is equal to the centripetal acceleration. It's like when you have a mass attached here, and there's a wire, there's a string, and it has some tension T, right? So here tension is equals to mv square over r. The same way you've got magnetic force that's trying to make this electron go in a circle, and because it's going in a circle, there's also centripetal acceleration towards the center, and those two things are equal. That means that mv square over r is same as 5.56, I'm just using this here, times 10 to the minus 13 newtons, and m times v squared and V is given to us as 9.4 times 10 to the 6. So 9.4 times 10 to the 6 squared, and this is the radius, and this is equal to 5.56 times 10 to the minus 13. And if you multiply both sides by r and divide both sides by 5.56 times 10 to the minus 13, you'll get m times 9.4 times 10 to the 6 squared divided by 5.56 times 10 to the minus 13. This is equal to r, and mass of the electron is 9.1 times 10 to the minus 31, and this will be squared, and 5.56 times 10 to the minus 13 will be the radius. Let's solve this. So we've got 9.4, so 9.1 times 88.36 10 to the minus 13 plus 12, and this is 5.56 times 10 to the 13, and this is equal to 144.61 times 10 to the minus 1, and this will be 12, or radius equals to 1.44 times 10 to the 10 meters, which is incorrect. Which cannot be true, because this cannot be true. Okay, all right. Yeah. So this right here is not minus 13, it's minus 31. This means right here it will be minus 31. This means right here it will be minus 31 plus 12 plus 13. Okay, let's do this again, because I don't trust myself with anything else. Sorry about this. This happens. Part of the process. 9.4 times 9.4. So 88.36 times 10 to the 12 times. I know you guys have much better calculators than me, but you gotta work with what you have. This is for sure minus 13, and this will be 144.61 times 10 to the minus 31 plus 12 plus 13. Okay, so it's gonna be So it's going to be 144.61 times 10 to the minus 6, which is same as 1.4 times 10 to the minus 4 meters. Here's your final answer. I just realized I could have instead of doing this way, I could have cut down the calculation if I had just used this acceleration. And this acceleration, let's write down here. This acceleration to be equal to the acceleration due to centripetal force. This would mean I would just do 6.1 times 10 to the 17 is equals to just this part, v square over r. This would have been an easier calculation to do, but anyway, so we learned something here. That's question 5 for you. And this is also an important one. Make sure you do it, understand completely.